Hey, hi Hari. Good
Yeah, hi,
morning.
Shiva.
Yeah, how are you?
Good. Shiva, I didn't get a chance to complete the assignment which you provided.
Okay,
I went through all the videos.
okay,
Things are new for me, but I am going through all those things.
okay. At least are you able to understand things?
Yes. So far, I understand what we are doing, how the code uh, pro- proceed to the next step. Yes.
Okay, yeah, that will be great. Okay, let me wait for uh, 3 4 minutes.
And Shiva, I remember you said you have some videos for the non-Java guys, right?
Yep,
Is it possible if you can share? It will
yep.
be
I will share it with you. I mean, if you're not from non-Java background, I can share it with you. Okay.
so much. I really appreciate it.
Yeah, sure.
Morning, Shiva.
Good evening, Mamta. Okay, let me get started then. Let's Yeah, let us to join slowly. So, to quickly recap what we discussed the last week, we have seen how to write a class, how to write a Java, Java equivalent Scala classes, and how to create objects for them, and how to declare methods inside them, and how to declare constructor variables or constructor parameters and class level variables and their access modifiers, private, protected, and public. Okay, and auxiliary constructors. How to define auxiliary constructor? We have also seen like on the packages as well. So we have seen a couple of examples on the inheritance, both in Java and as well as in Scala, and we compared what all things will be uh, extendable. Okay, so something like we can override only the vals, but not the vars in class constructor parameter. And for overriding class variables inside the class, if you have declared either var or val, so both of them you can extend. But a val is like a redeclaring the constants in the child class. And you will have a 2 copies in Java, whereas in only 1 copy in the Scala. Okay, methods with varargs we have seen, and launching an application with an object, either by extending an app trait or by writing a main method inside that object. So both of these ways are like writing, either you extend as an app or implement a main method inside your object. So both the scenarios, it is an object, not a class. Okay, so your applications are launched from an object but not from a class. That itself tells that Scala is a more pure object-oriented language than Java. Java, for suppose if you want to execute some lines of code, sometimes you don't even need to create a new object. You declare a class, public class, inside that write your main method and write all your println statements or whatever it is. So write your static methods and call them from your printlns or whatever, wherever it is. You can execute and print the results also without any object creation. So that's why your Java is not 100% object-oriented language, whereas your Scala, even if you want to print hello, you need an object already present. Okay, so till that level we have discussed, I think, creating singletons with object. Yeah. So this is again like the same point. Scala is more object-oriented than Java, and that's the reason we don't have the support for static methods. Okay, so if you remember the concept of the class level variables and the object level variables, and class level methods and object level methods. Okay. For suppose, let me take an example maybe. Yeah, Singleton test dot Scala primary constructor test. Let me see. So these things we have seen, auxiliary constructors. So what I am trying to show you now is Pizza Java test object at Scala. That's fine. Pizza test Java, static public void describe. Static public void describe, and your public static void main string args. You don't need to create a or let me make this way. Public class pizza test Java. So inside this, let's say I have a main method, and from which I am going to call, so println of, or just I will make a call for this. Okay, pizza Java dot describe. Okay, so here, am I creating any object inside this anywhere?
It's a static, right? So static, you will have only one. You cannot create an instance for static ones.
Yeah, I don't have not even one. I'm not creating any object here. So this is a class level method. So if I run this, it should print me something. Main method not found in pizza test Java. Please define the main method. This is due to other classes failed there in the build of this. That's why you don't get that. Let me put it here. Sorry. Yeah. I'm keeping you guys on mute so that I'm getting some background noise from your end. Yeah. So if I run this as a Java application, let me see. So yes, called Java successfully. So this is my class, pizza test Java public class. Inside this, I have a main method. So inside this, I have a static describe method. And I don't need to create an object for this to call this. So just the class name dot describe, call the method. That's it. And static protected, let's say int I equal to 100. Okay. And if I want to access that the same way, sysout or println your pizza Java dot pizza Java dot I. Yeah, pizza Java dot I. I'm able to access that without any errors here, right? So the static fields or the static members you are able to access without even creation of an object. But other than the static ones, you can access them only through object creation. Let's say I have a like a public void print message. Okay. So here, once again, sys out. Print message is a non-static method. Okay. So if I try to call that, I will not be able to call that. So pizza Java dot print message.
You cannot call this, right?
This is not possible to call this. Cannot make a static reference to the non-static method print message from the type pizza Java. So this is not a static method in my class, and that non-static method you can't call this way like a class dot method name signature. Whereas you can call this as new pizza Java. You create an object for this. You create an object new pizza Java dot print message. So if you create object, then you are able to call this. Okay. So this is the Java behavior. Now coming to Scala, how will you achieve that? So we don't have the concept of static at all. So without object creation, nothing is possible. That's why we use a Singleton object created already there. So if I have to achieve the same functionality in Scala, so what I have to do is right click, create a Scala object. Okay, Scala object. Okay. Singleton object test. Okay. So this one I call here. So now, what are the things I needed? Let me put these two. I don't have the var protected var I equal to 100 and def. What is this method? Def describe. Okay. It just prints the println of Scala successfully called static method. Okay. Let me keep those two. And now, so if I want to execute those two, I will maintain another object in the same. in order to call that, okay, object Singleton object extends app. This you already know this, right? Now, so what I am going to do is Singleton object dot. So describe for describing that, and println of Singleton object dot test of
Shiva, do we have to give the same name for both objects?
both
Oh,
objects.
there is no test. Okay, got it.
Okay. Yeah. I'm trying to do is I need to access the there protected, or if I just declare it as a var. Yeah, if I declare it as a protected, only the subclasses will be able to access that. Now I can see I from there. So protected is only accessible by derived in Scala, right? Not just the here. Now, the same functionality you are getting from here. With the help of a Singleton object. So now this object, whatever the object that I have created here, so this will be only one instance for your entire Scala application. So this object will not get created again and again. So if you observe the usage of the Singleton object, it's the same as like your static methods and static fields are declared inside a Singleton object, and the same feature as you calling them or using them, the static fields or the static methods, just the class dot method or the class dot field name, the same style you are calling those fields or methods present in your Singleton object. Okay. Here inside the Singleton object test, so whatever the field that you have, you're able to directly access it as like a class dot field or class dot method name style. But here this is not a class. Of course, this is an object and this is an object, but it looks like that style. And you achieve that functionality without you need to create an object again. So this is already an object, Singleton object, and you're able to call the method and field names from here. And for the non-static feature, okay, you still have to maintain a class. So Singleton object test. Okay. And you are not maintaining any constructor parameters for this. The other method, what is this? You have print message, def print message. So this is how it is not printed here. Println if I call that this way, dot print message It's not possible. If you see the error message, value print message is not a member of object singleton test. It's a member of class. It's not a member of object. But if you make this as see, so if you create an object for this class, then you are able to make this. Okay. So for your class level non-static methods or non-static variables, the same behavior in Scala. You have to create an object and make use them. And if it is a static method or a static variable, you don't have the static keyword in Scala, but you can achieve them through the singleton object. So anything that is declared as a static method or variable, that is available across all the objects, and that is available at class level itself and can be used with any object, right? So in any, at the time of processing any object, if you want to access those class level variables, so that is possible. And even the concept wise, let's say if you have, so concept wise, if you have a static and non-static, if you have declared a class here and static something, static I or static describe, if I take the same examples and print message, and after this class, so if I call the class C1 this, okay, and if I create an object for this, so object 1 and object 2 and object 3. So your print message will be a separate copy. Your print message will be a separate copy inside each object. Okay. So they will have a separate references inside each object for your print message. And any other fields that you declare at class level other than static, they will also have a separate copy for each object, like all these variables having separate copy for each object. But anything that is static, that will be maintained only one copy in the class. Those are like a static variable and the static method. So even after you create thousands of objects, yes, one copy of your static variable or one copy of your static method is sufficient. So generally what we do is anything that is common for all the objects, we put that in a static method or in a static variable. And the same nature, a singleton object means you will not be creating again an object for that. So you're already declaring at the time of writing itself, this is an object, a singleton object. So anything that you declare, so that will be maintained only one copy, and that object will never get called again and again to create an object. One more instance. It's already an object that created once, and inside that, so you have a method and fields, and any non-static, or they will anyway have so many objects, so having their own specific fields and methods instances. Okay. So that is the purpose of your singleton object, and it solves the feature of your static methods and the static keyword nature. Okay. So let's see this one more example here. Since Scala does not support static keyword, we use singleton objects. And here, so for example, if you see, so one of the more useful one. So I have I'm importing calendar and simple date format classes from the Java packages. I am declaring one date utils class, and I have two methods inside this: get current date and get current time. So there is one more method which is get current date time, which is a private method, and this will be accessible only inside the object. So date time format, if I give in the string, so I call the simple date format by passing the string and get the calendar instance and format that the given date and time, and finally gives me the result of it. Now, so here I have two methods, get current date and get current time, declared in this singleton object date utils. So whenever I want to call them at any point of time, I can call them like the class name dot method name syntax. So here, so it look like that syntax, the same style, but it's an object. So you can use in any class or in any object, because this does not need to be recreated an object every time. Object creation is not a not ignorable thing in the JVM every time. So if you feel like there is any common nature, so create an object for that once and leave that as it is. Okay, okay, just give me a second. I'm going to unmute. Yeah, sorry. So this kind of a common nature, common methods are a very frequent methods that you feel like, and you don't need to create an object again and again because they don't change by the instance of your object. You can declare them in the singleton object and see you can use wherever you want. Okay.
Here instead of static, object is the keyword, right?
You should not take that like a straight formula kind of thing. So the concept singleton object means, so it's an object will be created once, and inside that, so each of the methods that you have declared, those are available at object level. And
yeah, that's fine, but only for me, I just wanted to differentiate between Java and this, because there we say class, public, static, whatever it is, it should be public. So static, and here we are not saying class. For other things we mention the keyword class, but here we use object, right? That's where my focus is. I know the concept.
Syntax wise, we have blind sign, you can keep that in mind, but yeah, so that is not a straightforward rule or something like that. Okay.
Then is there any other way to create singleton object?
So singleton object is using only the object keyword and the name.
Yeah, that's what I wanted to know. Okay, yep. Thanks, Shiva.
Okay. Yep.
The concept, it's fine because it's only one object, only one.
Syntax wise, if you want to keep that way, you can remember that way.
Okay, thank you.
Okay. So now I created a singleton object. I'm able to call them and you can even test that in your Eclipse also. So Singleton object extends by app. What is app? App is a trait that we have seen in the last session. Like, you can make a Scala application as launchable or executable application two ways: either defining a main method inside that or extending an app trait. App is a trait. Trait means an interface here in Scala. Let's see those traits and interfaces in the next session, the next section today itself. Okay, you will get to know. So what does mean by a trait? So these are some of the conclusions for this Singleton object. A singleton can inherit methods from other classes and traits, which cannot be done with statics. And this is the difference between the exact static keyword and this singleton objects. So since this is an object, it is able to extend a trait also. You just have seen extends app. Whereas if you have a static method or static fields or a class static cannot be instantiated, right? So from other classes and traits which cannot be done with statics. So a singleton can exist within the scope of a surrounding class or method also. That means a singleton object can be created inside a class or inside a method as well, and they will be treated as like inner classes. Okay, and it's also worth noting that a singleton does not have to be a companion, and it's perfectly valid to define a singleton without also defining a companion class. So this statement you will better understand in the next slide. Okay. So what does mean by a companion object? The same example I will make use to explain it very well. So here in my Java, I have Pizza Java is my class. I have both static methods and as well as non-static methods declared in the same class. But I don't have that facility to declare both static and non-static methods in the same class. Here, inside my class, I can only declare the non-static methods. And if there are any static methods, I have to create a singleton object. And inside that, I have to write my static methods. Correct? If I maintain the singleton object name, which is same as your class name, then this is called as your companion object. And if they both are written in the same .scala file, there are two constraints. So your singleton object name should be same as your class name, and it should be written in the same .scala file. Then it is treated as this object, singleton object test, is treated as a companion object for this class. Whereas singleton, just a singleton object, this is not a companion object, but this is a companion object. Because it has the same name.
What is the difference, Shiva?
Since it has the same name, we call it as a companion object. So since it is not having the same name, so both are singletons only, but the extra name that we give it to it is companion object. Now, coming to the differences, you can access all the private variables or anything same like your Java. So anything that you have present inside your class are accessible by your companion object, and anything that are present in the companion object are accessible by your class, even if they are private methods or private variables. That means
Can you
they
please
both
repeat?
will have the same scope. They both will have the same scope, like a same the class name here.
Shiva, can you please repeat this if you don't mind?
Yeah, I will explain you this with the help of the next example here. Okay, so that will make you better understand. So static methods of a class can be defined with Singleton Object, but instance methods, which are non-static methods, need to be defined inside a class. If we define non-static members in a class and static members in an object with same name as class, then that object is known as a companion object. And just an example, pizza class and pizza companion object. So here I have some vals, some crust type thin, crust type thick, and get through. These are the methods, and this is one method that is present in the pizza. So this is a non-static method, and this is a static, and these two are static fields. Now, so to explain you the scope which you asked me, let me explain with the help of this example code. So here, let me run this and show you here. Okay, so companion object test. Control Shift F. I have a class foo here, and inside this, a private val secret equal to 2. So this is a, ideally speaking, this should be visible only inside your class. Okay. Even if I create an object of this, I should not be able to access this. Correct? Same like
You can access within the class. If that day we have seen, right? We can access
within the class you can access. Within the class you don't even need to create an object for that.
Yeah.
So private means if you're not able to access within the class also, then there is no point of declaring that.
Yeah. So outside you can't.
Yep. Outside I can't access that. Now, if I try to access this secret outside of this, so val secret, I declare it as a private here, and I'm trying to create an object for that. So here new foo f dot secret. So value secret in class foo cannot be accessed in foo here. So it's telling that I will not be able to access this. Okay.
It is indirect, right? You are not accessing directly. Okay.
Let me complete this explanation, Mamta. Let me complete this. Okay. So this private variables, even if you create an object in some other objects and some other program, you're not able to access the method. So only option is you have to expose a public method on this and make it exposed. But that is not my intention of this example. First of all, let me not worry about that. So my intention is that, so these two are having the same class name, means same like your Java, you will be able to access these private variables within these two like this way. So object foo has the scope or the visibility for this variable. So if you check here, I have a double method foo which takes an object of foo, and inside this foo dot secret, so it can now access this. Of course, if I have to access this inside the object, I have to create an object for this, but still the scope of your object foo is it can see any private fields also inside your class. Okay. Now, let me put this also there. So this, if you try to execute this, so it will run. So it's able to make it as 4 and print it there. So that's why you can see the 4. Now, the other way, so the private variables declared inside a class are visible for your companion object. And now, if I declare any private method or a private variable inside the object, those will also be visible inside your class. Let's see that example as well. Okay, so let me define a private val obj. Okay, so now we'll declare private val obj companion objects private val. Okay, so now I'm going to define a method inside my class in which I'm going to access this thing. So def print obj, its definition is this println of okay, sorry, I missed the ending quotes. So its definition is that println of s I can see foo.obj. I'm using dollar here, and since I'm following this syntax, so otherwise I don't even need to give that. Maybe you might be confusing that it is because of the dollar symbol. It's because of dollar symbol you might be seeing this. Okay, so even without that you are able to see this. So why do we use dollar sign while printing? Is it for formatting? No. I have shown you this at the time of strings itself. Substitute strings. Inside the substitute strings, the advantage is that you can even access the variables without closing the double quote strings and making a plus again and again. I have shown you this thing when I was explaining you the Scala strings for the first time. So if you make a substitute string, so you can access your variables inside this. Just no need to close the dollar. So just make, okay.
Got it. Yeah.
Secret. You can access the secret value here. Okay. Now, so this is same like object dot your class name dot. That is different case. Okay. Don't worry about syntax how you are calling. So here you are, after creating the object, you are accessing this. Here, just by the object name dot obj, you're accessing this. So if you keep that syntax aside, but the scope is available or visible, right? So anything that you declared even as a private inside the companion object is visible inside the class, and anything that you declared as a private in class is visible in the companion object. Vice versa. Okay, so each one of them can see the other's private things as well. Okay, so I didn't call this. Let me call the new or just f dot print obj. Then it will be able to print that. I can see two companion objects private val. Okay. So that's the concept of companion object and its a scope.
So what is the exact difference between the companion object and singleton object?
Yeah, exact difference means the companion object name should be same as your class name, and it will be defined in the same .scala file.
Shiva, what is the need? How do we benefit from that?
I told you, right? You can separate your non-static nature into class and static nature into companion object.
Okay. It will be like a same class, but you are making those.
Here, that's why I shown you this thing. Here in this class, you have both static nature and as well as non-static nature. So I divided this into two in Scala. All the static nature into companion object and non-static nature into the class.
Okay, got it.
Here. Yep, here. And your just a singleton object name can be any name, and it's like a singleton, and inside that you can write any methods and you can use them. Your companion object is in turn a singleton object only, but if it has the same name as class, so then it has the scope for seeing the private things also. Okay. So now, yeah, similarly, instance member, that thing we have seen. So creating object instances without a new keyword. So far we discussed singleton object and companion object. Now, let's see one more new concept here. Creating an object without the new keyword. So till now, we were creating the objects. So here, we were creating all the objects using the new keywords, right? So here also, just by using the new keyword, I'm able to create the object. So without the need for new keyword, how can I create an object? And what is the need for dropping off that new? So it makes sometimes more readable and more understandable. Okay, the look-wise, it looks better. For example, if I take val A and I have a person class and I want to create an array of those persons. Okay. So if I'm going to declare an array of persons, and where person is a scalar class, and every time I have to give is new space person of Ram, new space person of Krishna, new space person of Shiva. So it seems like repeating, right? Person Ram, person Krishna, person Shiva. That way you will be able to understand this. It's an array of persons, and you are deprecating that new keyword. So to achieve this functionality, you have two ways in Scala. So one is writing an apply method inside the companion object, and second is the using the case classes. So what does mean by a case class? We'll see next. First, let me complete the first part explanation. So if I take a person class, and yeah, this gives you so one more way of defining multiple constructors. So we have seen primary constructor, we have seen auxiliary constructor there. And the same achieving the nature of auxiliary constructors with the different parameters list is possible this way also. Here in this also I can show you one more way. Now, if I'm going to declare this, let me create one more Scala object like what is this? Case class functionality. So I have a person, and the person object companion object and apply method. As I was telling you, so in order to suppress that new keyword, I can achieve by defining the apply method inside that. Now, let me write this extends app. Now, inside this, so if I want to create objects, any objects, like class val Shiva equal to this, or I can declare this way. I can just declare that, and a dot for each dot for each x println of x. Okay, so I'm able to run this, right? So without any syntax errors, so it's accepting this.
What is that?
It's a string object I'm trying to
That
right?
the extra person at so and so.
Yep. So since this is an object being converted to string, you will see that kind of numbers. If I just accept the name, extra name, so I can see this. So without the new keyword, I created objects for this. Correct? So just if you see the definition of apply method, so apply method is taking that name as parameter, the constructor parameter, whatever the string that you are passing, that name string, and its return type is a person only. Okay, the same person class only I'm going to return object of that. So where p equal to new person, I'm creating an object for this person class, and I'm accessing this constructor, the class variable p dot name equal to name, and returning the name.
When you say new person, which class it refers to? The class, the private one? I mean, the class or an object?
And
Because
can you apply
object
a
is
new
only
keyword on
one.
object? Can you apply a new keyword on object?
No.
Then then there is no question at all, right?
So it refers to the class.
Yep, obviously.
Okay, thank you.
Yep. So inside that p dot name, so this points to this, and I'm setting the name whatever I receive from this. So here this person of Ram means, so this object, this apply method gets called automatically. So you don't need to specify call the apply method if you use this kind of syntax, the same companion object. So that's why if you want to suppress that new keyword, your companion object should have a apply method defined, and that apply method, whatever the parameters that it is taking, so that they will become your constructor parameters here. And if you want to declare one more field into this, var age, which is of int, okay, and I want to declare one more constructor for this, def apply name and age int. Okay, and here I'm going to make this as a p dot age equal to age, what I have to say. This will become my second constructor. Okay, this is a 1 arg constructor and this is a 2 arg constructor. So now the same stuff, I can create a val b with a two arguments at the same time. So val b equal to array of person of Ram, and his age is 30, and person of Krishna, his age is 35, person of Shiva, let's say his age is 28. Okay. Now the method name always need to be applied. Correct. The method name always need to be applied in your companion object. So here, now you are able to create an array of persons objects again with a multiple constructor parameters, right? And you can call the same stuff. So here, b dot for each of them print name plus age x dot age. Seems like there is any error. So class person needs to be abstract since variable age is not defined. Okay, it's just declared, so not defined. So it's asking me to Let me try to clean this. Yeah, so it has gone now. So in your Scala project, so one thing is that if at least one of your program is having any syntax errors or these things, you can't run even other programs also. So that's why when I was running here, so since these two programs were having compilation errors, so I was not able to run this pizza test java.java also, even though there are no compilation errors on this. I was not able to run this independently because it tries to build this entire thing as a project, and only if the build is successful, all your .class files and main methods will get recognized.
You can't exclude those classes?
So you have to remove them. If I have to run this, you have to remove these two, or you have to solve these error messages.
Okay, but there is no exclude option like .NET.
Your project level, you don't have that scope that you can run some of the successful, no compilation programs, no compilation error programs. You can't run if you have some of them with some errors.
Okay, but .NET you have that option. When you exclude it, it doesn't take it as a build.
So I'm not building, I'm not talking about build at all first. If I have to run them, first of all, it will try to build it, unlike your Java project. Your Java project, it will not build the entire project, right? So it will just...
No, I won't work much on Java. I'm aware of it, that's it.
Yep. So it will not build that completely. So it can run that independent program as well.
Okay, for each and every class you are writing this app method, which one it will execute when you have so many in the project?
So you are running that on that program from whichever program that you have to run. So from that program you run as Scala application.
Okay, got it.
Wherever the app trait is getting extended, so from there only you can make it as runnable. So here, so earlier I was not able to run this pizza test.java. So when I removed those two programs, it got executed successfully as called Java successfully from this program. Otherwise, oh sorry. So this is getting, so I'm not able to undo that removed files here. Otherwise, I could have shown you that back. Okay, I hope you got that thing. Now, so here what I am trying to show you is, so without the new keyword, you are able to create an object. So if you have an apply method defined inside your companion object, and so this is like your this is like a one arg constructor. So for person object, so this name parameter that you pass, it will create a one argument object. And the same way, if you define multiple apply methods with a different number of parameters, that is as good as defining multiple parameter constructors. This way, I have a one arg constructors created successfully. I have a two arg constructors created successfully. If I run this as a Scala application, so I can see here Ram 30, Krishna 20, 35, receiver 28. All these things.
How we use such things? Like, is it common or creating this kind of methods?
How big? What is your question?
I mean, how frequently, in the sense, do we use it most frequently in the program? Like, I don't know, like which way of constructor do we use?
We use this very frequently to have the constructors, multiple constructors. The two ways I have shown you earlier, using this method here, using this method, you can take the two parameters and implement that. So that is one way of writing your auxiliary multiple constructors, and this is another way of writing the multiple constructors. Either ways is fine, but these are frequently used ones only. Okay, not very rare kind of scenarios. You have to keep in mind them. But with respect to your Spark coding, you might not see these things that frequently. But yeah, before even making a statement on this, I want to give you the second way of doing this also. Then you will not be interested in the first way that much. For dropping the new keyword, for having a multiple variable constructors is fine. Even that is also not needed, I think. Yeah, you can even get that. So here, the second way of doing it is using the case class. Instead of declaring, let's say, I have a class person, class companion object person, right? So now I don't want those two at all. Case, I'm going to declare a class as a case, and I will make it as a person too. Okay, and it takes name as a string. That's it. Now I can still achieve that functionality. These two, let me make this time as a C. But this is a person 2, person 2, person 2. See? So even now, I'm able to create that.
Which is person and which is person 2? Can you please go up?
The person 2, I just declared this person 2. Or if you have confusion, I will put it here itself. Okay.
Okay.
The case class person 2, what is its parameter? What is the class variable? What is the parameter for this?
It's like the previously how we created, right?
Correct. So this is equivalent to writing this much of code. Writing this much of code, it's equivalent to this. Now, if I have a case class, it's two parameters, age, int. Now then I'm not able to create a multiple constructors for this case class. But if you want multiple constructors, so you can go with writing a different apply methods in the companion object. Okay, so that will solve the purpose of both multiple constructors and as well as suppressing the new keyword. But if it is just suppressing the keyword, and if you can give the default values for this, you have to specify this default values here. So multiple constructors nature you are not getting with the case class, but you are suppressing the new keyword with just one line of code.
Your signature should match, right? Basically, when you have a string and int, whatever it is, those should match to create.
Data types always need to match. Okay. Here, so what it does, the case class and behind the scenes is that, so it also creates a person to companion object by itself, and inside that it will have an apply method with these two parameters. So it will create an apply method with these two parameters, and it will additionally define two or more methods also, the Java equivalent, the 4 methods. If I run this here, and let me show you that hyphen Java P, right? So with that command -c here person2. So here you can see that. Now public person2 is the constructor which takes the, it's equivalent Java code this, which takes two parameters, string comma int, so field age and field name. Other than that, so there is an equals method defined by this case class, and toString method is also implemented in this. Okay, so if it is implementing the toString method also, and hash code method can equal and product iterator and product element, product arity, product prefix. So you'll not understand these things now at this moment. Product arity, product element, and product iterator. These three methods you will not be able to understand at this moment the purpose of them. But so in Spark SQL, I will tell you the limitations of the case classes. There, if you want to write your own custom case classes, then you have to extend these methods, extend the product class, and you have to implement these methods. Then that time you will understand the usage of them. But as you can see here, in the case class by default, for those variables, you have the getter methods. These two are getter methods. That means the variables that you have declared inside your case class, the parameters you have given here, so by default they are vals. And you can see the getter methods and hash code equals method implementation, and hash code implementation, equals implementation, and constructor implementations. And where is your apply product arity? Copy default, copy. Yeah. I think it's internal. It's not even visible. But case class generates an apply method in a companion object. Okay, not inside this. Not inside the class, but it should be $. Let me see. $. Apply. So behind the scenes, if you have a if I have a person class, let's say, so this will get compiled as a person.class, and whereas your person singleton object will get compiled as a person $.class. That's why I'm able to run this person2$ as well also. So you will, whenever I create a class in Scala, so that class name dot class will generate it after compilation. And whenever I create a singleton object or any object, that object name suffixed with the $.class will generate it out of that. Even that will get compiled, and a .class file will get created for that. That's why here a person2 is a class, and if I make it as a case class, by default it automatically writes its own companion object with some apply methods, as you can see here. So person2$ apply method which takes two parameters, and this unapply also is there. Not much used anywhere directly, and this is also apply, another variation of apply with two objects. Okay, so you don't need to worry this much of internals of this case class, but we use these case classes very, very, very frequently and very heavily in Scala. So it's as good as declaring a beans, Java beans, Java pojos, Java DTOs. So if you want to declare an employee class inside your, it's a pojo, like a plain object, Java object. If you want to declare that in Java, so you will define 3 or 4 variables and declare getter and setter methods and constructors for them. So that much of code you have to write. So the equivalent for that is very simple thing in Scala. Like, let's say if I have to return an object, let me take another Java class. Okay, employee. I have to write this. String name. Okay, and int age, again string department. Okay, so this is a plain pojo, or let me take one more field, string role. Okay, the role of employee. Now the source generate getters and setter methods for all the 4 methods, 4 fields. So all of them are generated now, and let's generate the constructor using the fields. It's as good as this. So you have to write this much of code in Java, and you have to make use of all these things. Whereas if I have to achieve the same functionality here, so I just declare that as case class employee. I can't use the same class name both in Java and Scala, right? So that's why I made it as employee s. So name, age, and what is that one? Name, age. After that, department string, role string. Okay, so that's it. If I want to create an objects now, val b equal to, so 2 ways from your employee. Try to access that employee of Mamata, age, let me make it 30, and what are the other fields like department IT and role TL. Okay, so I'm able to create an object for your Java class here. This is also an example for calling a Java classes from your Scala classes also. But yeah. Now, if I want to print this, println of d dot get name okay, and d dot get age. I have to print the same stuff. d dot get department d dot get role. Okay, so this is, so in order to create an object of this, and you have to create this much. Now if I have the same employee s class here, if I, so with one line of code, val e equal to, okay, just employee s of same, this time Madhavi, okay, and let me make 32 IT and TL. And how can you access them? E dot, what do you want? Name. And let me put this way. Dollar E dot age space dollar E dot department space dollar E dot role. See, it printed Mamta 30 ITTL and Madhavi 32 ITTL. Same functionality. So if you see here employee.java, this is a POJO or a DTO for carrying all the employee attributes. I declared them as a fields, and I declared one constructor, and I declared some getter and setter methods. So I had to write a 40 lines of code here, whereas the same functionality I'm able to achieve just with one line of code. Case class employee yes, here it is. The equivalent code for employee.java is just one line of code here. It makes your developers' efforts so seamless, like it reduces developers' efforts a lot. And we use these case classes very, very, very frequently.
This is for setting the getter and setters case.
Getting setter and getters, and no need to define the new keyword, everything.
Okay, so when you say case, it is going to automatically set the getters and setters, right?
Yep.
Okay.
Okay. So getter methods will be available. If you don't specify as a val or var, by default it's a val. You can't set them. If you want to have the setter method also, then you have to define it as a var here.
In case if we, let's say I pass 3 or 4, whatever it is.
Yep.
For one of it, I don't want I want the set method. I don't want the getter method. How do I achieve that?
You don't want the?
See, I have four variables, right? So I get the getter and setter for both, whatever parameters I pass.
Yep.
So for one of it, let's say department, I just take it. And for some processing, they don't want to set the department.
Okay.
Okay, so how do I achieve? I don't want a setter method for this.
Yeah, this is how exactly. So now here, name will create both setter and getter, but for each department and role, you will only have a getters, but not setters.
How do I know there is no setters? I'm not getting it. I'm getting confused here.
Okay, for your confusion, so what I am telling you is that, so if you have a var, you will get both setters and getters. If you don't
Okay.
have a var, by default, it's treated as it's as good as like a val.
Okay.
Val
It's
means you
only
will get
getters.
only getter.
Okay.
You can even explicitly specify it as val, or even if you omit it, its default behavior is val.
Okay, got it. Only when you say var, getter and setter, when you don't mention anything, it will be considered as val. So
Correct.
it's only setter methods.
Yep. Correct.
Getter methods. Okay. Thank you. Yeah, it's easier here.
Yep. So yeah, so that way it is. So I mean, it reduces lots of developer efforts. Okay. Now this is an example for that multiple constructors with additional apply methods. Anyway, apply with just the name parameter and apply with name and age, two parameters having the constructor. We have seen already this. And case classes, we are already discussing this. Case classes are nothing but similar to Java Beans or Pojo or DTO. Basic syntax of case class is this case class person and all your fields and their data types. That's it. This saves a lot of code and time for developer. By default, case class parameters are val. This is what I was telling. Okay. And so one more thing is that we have seen this case classes automatically define hash code and equals method and apply methods in the companion object. Case classes automatically define getter methods for the constructor arguments. Setters are not generated for case classes unless var is specified in the constructor argument. Now, one more feature with case classes is that case classes can also be pattern matched. So in pattern matching, we have seen so far, you can compare, you can pattern in your switch case, case statements. You can use your basic primitive data types, integers, strings, and floats, doubles, and all. Also, we have seen, we were able to compare one list with another list in the case statement. Here, this is the same extension, like similar to that continuation. You can even compare, you can even match case classes as well. So if you check this example, case class person to var name equal to string, I'm creating two objects, var A with Shiva, var B with Ram. So I'm going to define a function P person2, P match person2 of Shiva, println Shiva, P match case person2 of Shiva. So here this is a case class object, right? This is a case class object. Be able to use those case classes inside your pattern matching as well. So val f equal to function of a. When I passed a to it, so a means this object. If I pass this object, so it is able to compare that object with this person 2 of Shiva, and it's printing me Shiva. If I pass B, so it prints me Ram. Okay. So case classes can also be pattern match. That's the conclusion of that. Now, yeah, next let me complete these traits and abstract classes for today, and remaining topics we can discuss tomorrow. So how frequently we use this kind of method? I think I already answered this question.
Yeah, you have already answered that.
Okay. So now
when you have case statement, I don't think it's easier, I believe, more for most of the filters and all those, right?
Case classes?
Mm-hmm.
Case classes are more frequently used. I mean, what are the scenarios that you feel like you can't achieve with case classes, but with Java?
It's easier, right? When you get the anything from the database or anything, just create a case class,
Correct.
send it to
Exactly.
list and filter it.
Generally, I mean, whatever, if you have any tables in database, their equivalent POJOs, beans, or DTOs, and you are writing your Java project with respect to the DB tables, right? So if you have a person table, if you have a customer table, if you have a employees table, so for equivalent to them, we create a Java POJOs in Java project. Here, you don't even need to write that much of code. Even if you have 20 fields or 15 fields, so your Java code will become very huge. If you have just for 4 fields, it became 40 lines. If you have a 10 more or 15 more fields, if you have 20 fields, it may go beyond 100 or 150 lines of code. Even more than that.
Where basically the business objects are.
Yep. Whereas your case classes will still be a one single line of code. You just have to specify all the list of fields. This is as good as your table definition, right?
Yeah.
So if you assume this is a create table instead of case class, create table name, your syntax. That's it.
Yeah.
Same like your SQL syntax.
And especially like if you apply this on the list, you can filter it out, right?
Yep.
If you create
you can. So if you create a list out of that, so it's as good as table data.
Okay.
Same like your table data then.
Then you can filter it and you can do everything.
Yeah, that's why you will see more examples on this even in Spark SQL. That's where you might need to write some custom classes also because of case class limitation. You will write custom case classes. That example I will show you there itself. Let's worry about it. That here. Okay. Now, so I have 20 more minutes. Let me complete the traits and abstract classes. So you are asking me, what is an app? I told you that app is a trait, but you don't know what exactly a trait means. A trait means same like an interface in Java. When I say same, it's not 100% same. Its functionality a bit similar to that. And a trait encapsulates. The purpose of interfaces in Java is to specify your method declarations and field declarations, but they may not have the implementations. Right? Interface in Java. So interface. So interface my int. Inside this, I have a couple of methods. Okay, public void method 1. Just a declaration. No definition or no implementation for that. So public void method 2 and a public field or public or whatever the field is, public string equal to string str. Just declare them. So if you just have a declarations but without the definition of those methods or without the implementation of those methods, then that is treated as an interface in Java. The same applies here also for trait, but here we named it as a trait. So a trait encapsulates method and field definitions which can then be reused by mixing them into classes. Unlike a class inheritance, in which each class must inherit from just one superclass. So if you have a classes, so if you have some methods inside a class, And if you want to use those methods, you have to extend that class. But if you extend that, that is inheritance, right? So with that extends, we don't have a multiple inheritance concept. You can't inherit multiple classes in Java, right? You can't inherit multiple classes in Java, whereas you can implement multiple interfaces in Java. The same way in Scala also, you can implement multiple traits. But here one thing you have to keep in mind is that we don't have the keyword of implement in Scala. They wanted to reduce as many keywords as possible. And since it's also the same nature of extending the trait methods into your class, right? You're trying to get the interface methods into your class. That is nothing but extending that. So that's why we make use of the same extends keyword even for traits. That's why you see extends app there. Here, traits are similar to interfaces in Java, but in traits, we can have default implementation as well. Now, it looks bit similar to,
new, right?
Yeah. Now, it looks bit similar to your abstract class, but this is not a class. This is an interface. This is a trait. We do have abstract classes also in Scala. There is a difference. We'll discuss that later. But even if the trait is having the default implementation, this is not a class. This is trait. Okay. When a class extends multiple traits, we can specify extends for the first trait and width for subsequent traits. This syntax. Class who extends trait 1 with trait 2, with trait 3, with trait 4, and so on. And example traits are here. So trait vehicle, define drive method. So drive method is just printing the println of driving, and define race. So I don't have def race. I don't have the implementation for this race. Now, if I have a class car, sorry, if I have a trait vehicle, okay, I pasted something else. Okay. So define a trait vehicle. Now let me define a class car which extends the trait vehicle, and inside this I am going to provide the implementation for race method. Def race equal to println racing the car. Now if I create an object for car, like a new car dot race, I can call this racing the car. Okay, and new car dot drive. So it's printing me the driving. Okay, the same implementation given in the trait that is getting printed here. Now, if you want to override that, you don't want that the same nature of the driving, same implementation of your drive method, but if you want to have a different, like that, you can give override def drive equal to println of. So overridden the trait drive method. Okay. So if you want to override the drive method implementation present in the trait, you have to give the override keyword. Otherwise, it takes it like a parent, the trait default implementation. And if I create without the override keyword, it throws you an error message. So def drive, so needs method drive needs a override modifier. Okay, and from your Eclipse, if you are going to create a trait, so you can use this new Scala trait. Okay, Scala classes we have seen, Scala objects we have seen, Scala trait we can create, and Scala app is something, the same thing, Scala object with like a test. So the same thing, object test which extends app, nothing new in this, not much useful. Yeah, that's why the more frequently useful ones are like Scala class and Scala object, Scala trait. Or I always go with Scala object. Inside that itself, I declare all the classes, all the anything, it's like a traits or everything, and make it as runnable. Scala package level object. This is something like the so object that gets created at package level. Something is there, but we don't use that much. Okay, it's a limited nature of your object. That is with respect to the component Scala related components in your Eclipse. Okay. Scala worksheet, anyway, you have seen that. It's like a Scala interpreter having on your Eclipse. Now, so if I have to use the same drive method in the class, which is present in the drive, which is present in the trait with the default implementation, you have to provide the override modifier. And so class boat extends vehicle, override def driving. So I gave that override, and def race. If I don't have implementation, then I don't need to give the override. I just have to provide the definition for that. That's it. So here for race, if you observe in both the classes, I don't have the override keyword. Okay, so that's what I have written here. If we do not have default implementation in trait, then override keyword is not needed. But if we have default implementation for a method in trait, we need override keyword in extending class method definition.
It is like a abstract class only, right?
It's similar to that only. We'll discuss the differences in a few minutes. Okay. Now, abstract class and traits. I mean, if you're curious, one difference is that abstract class, multiple abstract classes we can't extend, we can't inherit, but whereas you can inherit multiple traits. Okay. For the time being, this is the difference for you.
Okay, so in that case, we don't need an abstract class, right?
Let me come to that topic. Okay, so don't worry. I told you, right? I have abstract classes concept. Let me complete my perception, then we can discuss. Okay. So this traits with default having a methods with default implementation and without default implementation, we have seen those two, right? Now, in Java, we have a concept called interfaces, which can be extendable by only a subset of classes. Okay, so if you want to limit that way, limiting which classes can use a trait by inheritance, this slide may not be that frequently used in real time, but yeah, so I'm trying to give you this as well. So limiting which classes can use a trait. Not all classes, but only a subset of classes can use the traits. For example, I have a class A declared and trait T extends A. I am defining my trait T. This trait T extends a class. Okay? An interface extending a class. Extends a class. So class C extends A with T is allowed. I want you to catch these things.
Come again, Shiva?
So I define a class A.
Okay.
And trait, I am defining a trait T. So I didn't give any body for this, but don't worry about it now. So I am defining a trait T and extends A.
Trait is extending A?
Let me, Mamta, please. First, let me complete this, okay? Sorry for, I can't make every statement to statement interactive session. I might be like, first let me complete at least a piece of code, okay? So here, a trait T, I'm extending a class A. The thing is, if you keep on asking me for every line, I will forget what I'm planning to explain. That's my concern. Okay, I will have when I'm explaining one statement, in my mind, I will have a next sequence, what I'm going to explain next. I have to think, otherwise I will not make the next statement. So that's my my problem. Like, I will forget what I have to tell the next line. And in that process, I will repeat same line again and again, and it might be a bit frustrated for others. Okay. So I'm defining a class A. So here I define a class A. Okay. So it's giving me, and I'm defining a trait T. But here the limitation is that it extends A. Okay, trait T extends A. Now, if I define a class C which extends A with T, means this class C is extending both class A. So this is inheritance. And with T means it is implementing the trait T. So class C is inheriting A and implementing T in terms of Java terminology. If I have a class D, so extends T, it is also possible. So what is the constraint that I am putting here is, if anyone has to use this trait, either they should not extend any other class, or they should extend a class and that class should always be A. I'm not sure whether you guys are catching it or not. Let me repeat. So this trait can be used by any classes, But a constraint on that classes is that these are not all classes can use this trait. Only subset of classes can use this trait, and that subset has a constraint that either those classes should extend a class A or they should not extend any other class. Why I am telling any other class is that let me make class E. I have a class E. Okay, I have class E. Now let me define class F. Class F extends E. So if class F extends E, and also I want to implement the trait T, it's not possible. So what it means is that only the subclasses of A, if trait T extends A, only the subclasses of A can extend this trait T, or so any classes which doesn't have any inheritance, those two only extend this trait T. So this trait T can be extendable by any plain classes which does not have any inheritance, or only the subclasses of A. So here class C extends A means class C is a subclass of A. Whereas class F is a subclass of E and trying to implement T, it's not allowing you. Whereas class D is not a subclass for anything. In that case, if you want to extend T, it is allowing you. So in the last scenario, it is showing that error message, superclass E, illegal inheritance, superclass E, F is not a subclass of the type superclass A of the mixin trait T. So that means only the subclasses of class A can extend this if it is having any inheritance. That means, so trait can be, a trait T can be used by any plain classes, and I'm making that keyword, any plain classes, or any subclasses of A. Now we can go one more level deeper, and we can restrict the trait T to get used by just the subclasses of A, not even by any other plain classes. So there is one more restriction that you. So here, to achieve this functionality, how we define trait T extends A. So this gives you this nature, and there is one more way of defining your traits. That is, so trait my trait and this base type. Let's this and your class name. Okay, let me take this. So now base type also I will remove. So trait my trait, I am defining one more trait. Trait my trait, this A. And class A is already present there. So it defined my trait. Now, so if you extend this class X, okay, let me call class X, extends A with my trait. So here, so class X needs to be abstract. This is a different error. Okay. Since I am not providing a implementation for those two methods, it's not only. It is asking me to make it as abstract, but it's not telling me that it's not allowed. Okay. So when I make the abstract class X, so this is a class X, extends A with my trait. It is allowing me. Whereas, so if I have an abstract class Y, directly extending my trait, see, self type, class Y, it's a self type. Y does not conform to my traits, a self type of my trait with A. Illegal inheritance. You got the same error message. Previously also you got the illegal inheritance. In the previous example, here also you got the same illegal inheritance. So this error message is not related to that. Since you are not providing the definition for those two methods, it's asking you to make that class as an abstract. Same like Java. If you don't have a implementation for a method, then that is that you have to declare that method as abstract and the class as abstract. But here in Scala, you don't have to use that abstract keyword before the methods. Just specifying the before the class is sufficient. Now, so I'm able to make any. Now I made this constraint even more strict. So now this trait, my trait, can be used by only subclasses of A, not by any other class. Okay, it's not that much frequently used feature, but if you want to restrict, you can do this. Okay, now let me jump on to the most awaiting concept, abstract classes. Okay, so after this, I will give you a fast break for you, Mamta, so that we can discuss all your questions.
Can we discuss this abstract class tomorrow, because traits were not clear to me, and
it's just a matter of 5 minutes. Let me complete this. I want to make some conclusions between these two. Okay, so same like a trait is more or less similar to your interfaces in Java, whereas it has also the support. It has one extra feature that it can give you the default implementation. It supports you the default implementation, right? Here, so if you, instead of trait, if you make it as a class, that will become an abstract class. An abstract class, and same like your trait, even this cannot be instantiated. So abstract class is nothing but any similar to any regular class, where some of the methods have implementation and some of the methods just have a declaration but not the implementation. But not the implementation. They just have the signature but not the implementation for that. Okay, and though Scala has abstract classes, the Scala community recommends us to not to use abstract classes here, and to use, and it recommends, Scala community, developers community recommends us to use traits only. Because, why? Because if you have the abstract methods defined inside abstract class, and if you want to use inside a class, you can extend at max one abstract class. If you have multiple abstract classes, you can't extend all of them because multiple inheritance is not there. But Implementing multiple traits or implementing multiple interfaces is supported in Java. Implementing multiple interfaces is supported in Java. Similarly, implementing multiple traits is supported in Scala. And in extending multiple classes is not supported in Java. The same way, extending multiple classes is not supported in Scala. The same constraints. Okay, so we can extend only one class in both Java and Scala, but we can implement multiple interfaces or traits in both Java and Scala. So these two are two conclusions. And abstract class, whatever the abstract class feature that you are getting, the default implementation for some of the methods and for other methods not having any implementation, the same thing that you are able to achieve it through traits. That's why there is no strong point, the strong recommendation to go with abstract classes in Scala. Always it is recommended that to go with traits. Okay? And in case if you are extending abstract classes, the same inheritance concepts that we have discussed last week, they holds good here also. Extending an abstract class or extending a regular class, inheriting abstract class or inheriting a regular class, it's no difference. Okay? Meaning, if there is a var field in your abstract class, if you want to reuse that in your subclass, no need of override keyword. And if you have a constant val field in your abstract class, in your subclass, you have to give the override and val field also. These things we have seen already there. Abstract classes will have constructors, but not traits. This is one difference. This is the just one difference that you see. But even then, it's not at all recommended to go with abstract classes. If I have an abstract class pet var name string, and I have two methods, def speak and def owner is home. So this is an abstract method because I don't have a definition for that, implementation for that. For this, I have an implementation. So now I have a class dog, extends pet. Since this abstract class can take constructor parameters, so you have this, whereas in traits, you will not have that nature. That's it. That's the only difference. And def speak println. So here you're able to provide the implementation for speak and overriding the def owner is home. And similarly, so if you have a trait or abstract class, so var or val or var, so overriding them, so the concept remains the same as like inheritance. If it is a val in your subclass, you have to give override val. If it is a var, just start using them var equal to, field equal to your new value. Now here are the conclusions. So interfaces will not have constructors in Java. Same way, traits will also not have constructors. And thus, trait declaration does not accept constructor parameters. So below declaration is not valid. Trait test abstract, val year, var model. So this declaration is not acceptable, both in Java and as well as, so in Java traits, you can't have constructor defined, whereas abstract class can have. Whereas abstract classes in Java can accept constructor. Abstract class, that means abstract classes in Scala also accepts the constructor parameter. Abstract class test abstract. So now it can accept the constructor parameter. And in Scala, no need of abstract keyword prefixed for every abstract methods in an abstract class. But in Java, if you don't have implementation for a method, you have to make it as abstract inside an abstract class. And for the method that you have implementation, they don't need to be made as abstract. So that's the difference between Java abstract class and Scala abstract class. And you cannot instantiate Hello? Hey, sorry, it seems like there was a network drop. Okay. I'm just concluding in 2 minutes, okay? Just give me 2 minutes.
Shiva, is it possible to do it tomorrow if you don't mind?
I'm done, Mamta. Okay. So I'm just concluding it here. So
Because I really did not get the concept. I think
okay.
maybe the fresh
You
start
can
tomorrow.
revisit the same like once again, and we can see it. Okay. Yeah. So what I'm concluding here is that your interfaces. So what I'm concluding here is that your interfaces and traits, they function very similar. Only thing is traits will accept an extra implementation, the method implementation. That's the just one difference. Just because of that, so we don't recommend the usage of abstract classes in Scala. You are getting the same nature using the traits. And one advantage with using the traits is that you can implement multiple traits, whereas you can't inherit multiple abstract classes. Okay? So you cannot instantiate either interface or trait or abstract class both in Java and Scala. You can extend only one abstract class both in Java and Scala, whereas we can implement multiple interfaces or traits in single class in both Java and Scala. Okay, so we'll discuss the remaining topics tomorrow. Exceptions, and there is one problem that can occur with the multiple traits implementation, the default thing. Okay. So any questions for others at least? I mean, Mamta, you didn't get traits that I got. You just, I mean, can revisit that. For others?
Yeah, for me, my day is over. I need to sleep.
Yeah.
It's 12 almost.
Okay. What about others? Okay, not much clear, Shiva. Yeah, it really disappoints me, this statement. So I want to spend some time with you, Purushottam. I mean, like, what didn't you get, so that I can focus. What about others? Like Gopi? So traits. Traits is same like your Java interfaces. Only thing is you can have a default implementation also. There is no other difference. And forget about restricting your traits to a subset of classes. That's a very, very rarely used feature. You can just have a default implementation also in the trait. Is there any difficulty in catching that point?
It's not a problem. Like it's like a abstract class.
Yeah, that's why I'm telling you that it's almost like an abstract class, and don't use abstract classes here, and use traits only, even in place of abstract classes. Purushottam, still not clear? Just saying okay for the sake of saying. I mean, I'm trying to make you understand. At the same time, I may not be as interactive as like, so for every one line, I may not be that interactive. Okay. So at the end of each concept, if you stop me, I can explain you, but not at the end of every line. So that sometimes I'm forgetting. So that doesn't mean that you guys all have to be silent. Okay. So one thing that I am observing from you guys is that no one is asking me question. That is like, I mean, you all guys are so silent, which I didn't like, first of all. And Mamta is asking me so many questions that at the end of every line, she's not even letting me go to the next line and complete my conclusions. Before even I go to the conclusion or make a understandable concept, she is dragging me into the, I mean, like a discussion. So both the things are, I'm a bit worried about.
Hello, Shiva.
Yes.
Yeah, this is okay, but tomorrow you can just give one example, then we'll be fine. So we got some, not completely, but I got some.
Yeah.
Fine.
So I don't want others to be so silent. If you have any questions, stop me at the end of that topic itself. Okay. And I mean, when I say that, stop me, don't stop me at the end of each line. You both are at like two extreme ends. I mean, when I say you both, not just you, Purushottam and Mamta, I'm talking about others also. If you're not getting, so this, we are almost to the closure of Scala sessions. So it will be completed tomorrow. I will try to clarify any pending questions on Scala tomorrow. Okay. So I will just take up the exceptions and collections tomorrow. That's it. The building your Scala applications through Maven or SBT also, I will try to take it up as part of Spark applications directly. Okay. Even there we write the Scala, whether it could be a pure Scala application or a Spark application, that doesn't matter. Building process will be same. Or if I can spend five minutes, I can explain that build process also if possible. If time permits me tomorrow.
Okay. So, and from day after tomorrow onwards, what will be like?
Spark.
Okay.
Spark.
That is purely on not on Windows, right?
Yep, not on Windows. The same Eclipse, Scala IDE, same thing. All you will do it from your quick start VM. That's it.
But do we have to install this Eclipse Luna on VM also?
Yep.
Oh, I didn't do that. Probably like I'll try this.
Okay.
So because we already had one version earlier, so I didn't know what to do with that.
You remove it and have a fresh copy of it, latest copy.
Okay, let's see.
Okay. Yep.
Okay, thanks, Shiva.
Yeah.
But we have only 3 classes, right? This weekend. Sorry.
Yeah, tomorrow and day after tomorrow only. Next weekend, I will plan to take 1 or 2 extra classes. This weekend,
No extra classes on weekends, please. Weekends are tight for me.
Okay.
They're really tough for me. That's the reason initially itself I asked, is there a way
Okay.
to...
At least I mean, I need one class extra for next week. One class, I think, yeah. So let me check with others also. If no one is able to make up, then I will cancel it if no one is interested.
Okay, Shiva, it's time to sleep.
Yeah, you go to
Bye,
sleep,
Shiva.
Mamta. So I have few concerns with others. Like,
Okay.
so why? Yeah, you can drop off. You can feel free to drop off. I have few
Yeah.
concerns with others. Like, why? I mean, is there any difficulty, or you guys are not able to understand? Why are you so silent?
Yeah. I have to get ready for tomorrow and sleep. Okay.
Okay.
Good day, Shiva.
Yeah.
Bye.
Mohit, Madhavi, Gopi. Gopi, you said that you are able to catch up. I think you are from Java background. Correct. Okay. So, and Kalpana, you know core Java, right?
Yes, Shiva. I mean, today's topics are okay for me. First, I will go through the video tomorrow. If I found anything, I will definitely ask you, Shiva.
Okay. So, I mean, as long as you are catching up things, I'm happy. So, just sitting silent means it scares me. On the other hand, I'm okay even if you stop me every line. At least I will, even if I get forget, or if I get trouble, that's not a problem. I will still have a confidence that you are getting each and every point. But if you are sitting silent, that makes me even more like worried about it. It doesn't give me a job satisfaction. So that's why I'm trying to make you things up. Okay, it's not like I'm teaching to a wall, and let them listen if they want and let them leave if they don't want, kind of. Okay. So I too is from Java background. Okay, then I think if you guys are from Java background, it's not a big deal. Okay, it's just a matter of syntax change, one or two features, slight features here and there. So it's all thing is your code gets concise. That's it. Concepts remain same. Just one or two minor differences. That's it. Madhavi, I'm sure that you might have lost something. Am I correct? Or are you able to catch up? Madhavi, I'm not able to hear your voice. Yeah, yep. You can talk to me offline also if you have any concerns. Okay, seems like your son is crying. Okay, Madhavi, let me talk to you offline if you have any understanding gaps. Okay. Thank you very much. Thank you. Bye. Okay.